Good morning, all. So, in last class, we were looking at finding the derivative of parametric function. So, if you have a function which is represented parametrically in the form x equal to f of t and y equal to g of t, we were looking at the ways of finding dy by dx. So, that will be given by dy by dt by dx by dt. Then, we have also seen how to find d square y by dx square using chain rule. So let us look at one more problem on finding the derivative. So the problem is to find the slope of the tangent line to the unit circle x equal to cos t, y equal to sin t, where 0 less than or equal to t less than or equal to 2 pi at the point t equal to pi by 6. So we need to find the slope of the tangent at the point t equal to pi by 6. Slope of the tangent will be given by, so that will be dy by dx. So that will be equal to dy by dt by dx by dt. Now we have dy by dt equal to cos t and dx by dt will be minus sin t. So therefore the slope will be equal to minus cot t. So at t equal to pi by 6, the slope will be minus cot pi by 6, so which is equal to minus root 3. So that is the required slope of the tangent line. Now next we look at what are the conditions for the tangent line to be horizontal and the tangent line to be vertical. So given a curve, the tangent can be either parallel to the x-axis. So in that case it will be horizontal, and it can be parallel to the y-axis. So in that case it is going to be vertical. So we have the expression for the slope of the tangent line, that is dy by dx equal to dy by dt by dx by dt. ഇനി slope horizontal ആണെങ്കിൽ so the tangent will be parallel to the x-axis. So if the tangent line is horizontal, then in that case slope will be equal to 0. Slope 0 ആണെങ്കിൽ tangent line horizontal ആയിരിക്കും. Now if slope is infinite, then in that case the tangent line is going to be vertical. So let us look at what happens to dy by dt and dx by dt in that case. Let us look for the condition for horizontal and vertical tangent lines. So the tangent line to a parametric curve will be horizontal at those points where, so dy by dt must be equal to 0 and dx by dt must be not equal to 0. In that case we will get dy by dx equal to 0 at such points. So these are actually the points where the tangent will be parallel to the x-axis. So we will get a horizontal tangent line at these points. Now at those points where your denominator is 0 and the numerator is non-zero, the dx by dt equal to 0 and dy by dt is not equal to 0. So in this case, when you find out dy by dx, you will get an infinite value for the slope, and at those points where dx by dt equal to 0 and dy by dt is not equal to 0, we obtain a vertical tangent line. So this is how we find the points where we have a horizontal tangent line and vertical tangent line. So let us look at an example on finding the points where we have horizontal and vertical tangent. So find all values of t at which the parametric curve has horizontal tangent line and vertical tangent line. So the first problem is we have x equal to 2 sine t and y equal to 4 cos t, where you have 0 less than or equal to t less than or equal to 2 pi. So let us write down the value of dx by dt, so that will be equal to 2 cos t, and dy by dt equal to minus 4 sine t. So let us find the values where dy by dt equal to 0. So dy by dt is 0 when sine t is equal to 0, and in the interval 0 to 2 pi. So sine t is equal to 0 when t is equal to 0, pi and 2 pi. Now let us look for the values where dx by dt is equal to 0. So dx by dt is 0 when cos t is 0. So cos t is 0 when t is equal to pi by 2 and 3 pi by 2. So now let us look at the condition for horizontal tangent line. So for horizontal tangent line, so we must have dy by dt equal to 0 and dx by dt must be not equal to 0. And this happens when, so dy by dt 0 on t equal to 0, pi, 2 pi, and at these points we know that dx by dt is non-zero. So the points will be, so this happens when t is equal to 0, pi and 2 pi. അപ്പം നിങ്ങളിങ്ങനെ പോയിന്റ്സ് നോക്കുമ്പോൾ ഇവിടെ എവിടെയെങ്കിലും കോമൺ ആയിട്ടുള്ള പോയിന്റ്സ് ഉണ്ടോ എന്ന് നോക്കുക. അങ്ങനെയാണെങ്കിൽ ആ പോയിന്റ്സിൽ നമുക്ക് ടാൻജന്റ് ലൈൻ ഉണ്ടെന്ന് പറയാൻ പറ്റില്ല. ഓക്കെ, സോ next we look for horizontal tangent line, sorry, for vertical tangent line. So we must have dx by dt equal to 0 and dy by dt must be not equal to 0. So this happens when, so there will be no common points, so that will be occurring at the points pi by 2 and 3 pi by 2. So these are the points where we will have horizontal tangent line and a vertical tangent line. Question is, you have x equal to 2t cube minus 15t square plus 24t plus 7, and y is t square plus 4t plus 1. So when you find the derivative dx by dt, that will be 6t square minus 30t plus 24. So we'll get 6 into t minus 1 into t minus 4. So dx by dt is equal to 0 when t is equal to 1 and 4. And similarly dy by dt will be 2t plus 4. So dy by dt equal to 0 implies t will be equal to minus 2. So we'll get minus 4 by 2. So that is minus 2. So therefore horizontal tangent occurs when dy by dt is 0 and dx by dt is not equal to 0. So that implies t must be equal to minus 2. Similarly, vertical tangent occurs when we have dx by dt, so that must be equal to 0, and dy by dt must be not equal to 0. So dx by dt is equal to 0 when t is equal to 1 and 4. So at those points dy by dt is not equal to 0. So the values of t will be 1 and 4 for vertical tangent line, and for horizontal tangent line the value is equal to minus. So that's how we find the t values where the parametric curve has a horizontal tangent line or vertical tangent line. Okay, so let us look at another problem. Problem is to show that the curve x equal to t square, y equal to t cube minus 9t intersect itself at the point 9, 0 and find the equations for the two tangent lines to the curve at the point of intersection. Okay, so we need to show that the curve x equal to t square and y equal to t cube minus 9t intersect itself at the point 9, 0. അതായത് we need to show that for different values of t, xy will pass through the point 9, 0. So point 9, 0 we must get different values for t, and we need to find here the tangent lines at those values of t. So let us look at what will be the values of t. When we have x equal to 9 and y equal to 0, so that implies we have t square equal to 9 and t cube minus 9t is equal to 0. Now t square equal to 9 gives us t equal to 3 and minus 3, and from here we will get this will be t, then t square minus 9 equal to 0, so that will give t equal to 0 minus 3 and 3. So here the common values, so the values of t satisfying both the conditions are, so that implies here t will be equal to so we need to get x equal to 9 and y equal to 0. So x equal to 9 and y equal to 0 t values must be equal to 3 and minus 3. So at t equal to 3 and t equal to minus 3, the curve passes through 9, 0. So therefore the curve intersects itself at t equal to 3, t equal to minus 3, which is the point 9, 0. Okay, now let us look for what are the derivatives at t equal to 3 and t equal to minus 3. So we have x equal to t square and y equal to t cube minus 9t. So dx by dt will be equal to 2t and dy by dt is 3t square minus 9. So therefore we will get dy by dx, so that is the slope. So dy by dx will be 3t square minus 9 by 2t. Now let us first find what is the tangent at 2, 3. So at t equal to 3, dy by dx will be 3 into 9 minus 9 by 6 varum. So that will be 18 by 6, so which is 3. So therefore equation of tangent line at t equal to 3 is, so that will be, now our point we need to, the curve will intersect itself at the point 9, 0. For this will be the value of x naught and y naught. So we will have minus y minus 0 equal to, the slope is 3 into x minus 9. So the equation is y equal to 3 into x minus 9. So that is the equation of tangent line at t equal to 3. Now let us look at what happens at t equal to minus 3. So at t equal to minus 3, so when you take dy by dx, dy by dx is 3t square minus 9 by 2t